my colleague Michael Kleber and I are going to be telling you about what Chrome is doing to help people make safe decisions about what data they share with websites. If you're a web user in 2019, and I think most of you probably are, you've probably had some pretty mystifying experiences. You've probably had an experience where you're reading a news article on your work desktop computer when you stumble upon an ad for the exact pair of shoes that you searched for on your personal phone a week ago. No matter how many times you've seen ad experiences like this, it still probably throws you for a loop. How did this one website on one device know your search history on another device at a completely different time? And what else might it know about you? Or maybe you got an email, another mystifying experience, from your bank telling you to log in to verify a fraudulent charge or to unfreeze your account. And the email looks legit, the link looks legit, but how do you know? How are you really supposed to tell? And maybe even more importantly, how is a non-technical user supposed to tell? The fact is, it's not always easy to tell where you are on the web or what websites are observing about you. Chrome's goal is to help people with both of these problems. We want to help users make safe decisions while staying in control of their personal data. And we want to do this while preserving a thriving web ecosystem where content creators can make money through ads without invading users' privacy. We'll start by talking about what Chrome is doing to help people understand where they are on the web. What's the identity of the website that they're visiting? And particularly, is the site being misleading about its identity? As developers, this may be a problem that your users struggle with, or maybe even something that you sometimes struggle with yourself. Because even as expert users, even for myself as a person who works on a browser security team, it's not always obvious when a site is being misleading about its identity. In theory, the URL bar that's shown at the top of a web browser is your unambiguous clue to website identity. If the URL bar says google.com, you're at the real Google. And if it says evil.com, you're not, no matter how much the web content area looks like Google. But in practice, it's not always so easy to tell site identity from a domain, as you can see here with these examples. Some of these URLs might be hard for even expert users to notice and distinguish from google.com, much less non-technical users. And this isn't speculation. There's lots of research, lab studies, surveys, field experiments, showing that many users don't notice or understand URLs when they need to in order to make effective security decisions. In a study that we did with over 1,000 participants, we showed users a browser window where the website looked like a Google login page, but the address bar said tinyurl.com. When asked to identify this website, over 85% of participants said the website was Google, even though the address bar clearly said tinyurl.com. This presents a really hard problem. Lots of people use URLs for lots of really useful things. But there are also lots of ways that URLs can be used to trick or harm people. So what can we do about it? We're approaching this problem from a few angles. First, we're actively combating sophisticated spoofing techniques that abuse URLs to create unusually deceptive attacks. Second, we're trying to draw people's attention to the information in URLs that's most relevant for making security decisions. And finally, we're building specialized tools to support expert use cases so that we can help make URLs better security tools without interfering with experts' workflows. We've found that sites can be particularly misleading about their identity when they abuse internationalized domain names, or IDNs. These spoofing sites use non-ASCII characters in the domain to look remarkably similar to a legitimate domain. Suppose you are looking at example.com, as written here. You could do a very careful character-by-character comparison, and you'd probably conclude very confidently that you're at the real example.com. There's no way this is a spoof. But it turns out there's a Cyrillic character that looks identical to a Latin letter A. So this isn't the real example.com. It's a completely different domain, even though it looks the same. The question that browsers are faced with is, when is it safe to display non-ASCII characters in a domain, and when does it create a spoofing opportunity like this? You can see that with a naive IDN display policy, or even with a sophisticated one, there are many interesting avenues for spoofing that can open up. To combat this kind of spoofing, in Chrome 75, we introduced a new warning, which we call the Lookalike warning. This warning detects spoofy IDNs and shows this page to direct the user to the legitimate site when we think they might be under attack. Here's how this works under the hood. When Chrome encounters an IDN, an internationalized domain name, in a navigation, it converts it to a skeleton, using an algorithm that converts a representation of the domain, collapsing similar-looking characters into one. We then compare that skeleton against the skeletons of very popular sites, and also sites that the user has visited and engaged with in the past. If there's a match among one of those sites, we show this warning to direct the user to the legitimate site that we think is the site they actually want to go to. But of course, it's not only IDNs that are confusing and that present spoofing opportunities. Paths, fragments, and other components of the URL can distract from the domain name, which is the crucial indicator of identity that users need to scrutinize to make security decisions. You may have noticed some changes recently to how Chrome's Omnibox looks to help draw users' attention to the domain name. First, we did some user research on the extended validation indicator in Chrome. Extended validation is a special type of HTTPS certificate, which you can buy to tie your domain name to a legal entity. And when you do this, your legal entity name shows up in browser address bars, as you can see here. The idea is that this type of certificate relieves end users from having to understand site identity from URLs, because they should be able to discern it from the EV indicator instead. From our user research, though, we found that EV certificates don't really help people understand site identity today. For EV to be effective, people need to notice when it's missing, because that indicates a possible attack. But we found that they didn't. There have also been some recent proof-of-concept attacks showing that EV can even be abused to show actively misleading site identity information in the address bar. So in Chrome 77, we moved the EV indicator into page info, which is this UI surface that you see when you click on the lock icon in Chrome. If you have an EV certificate for your website and you're wondering where the EV indicator went, this is where. This is in line with our general philosophy on Chrome that users should be able to assume security by default and will warn when something is wrong. Rather than, we don't want to be presenting positive indicators and relying on users noticing their absence, because we've found that just doesn't work as well. We also recently launched a change to simplify how URLs themselves are displayed in the Omnibox. The scheme, HTTPS or HTTP, and the very common subdomain www don't add much information for many users. The scheme is most useful for telling whether the connection is secure or not, but we already represent that visually with a lock icon or a not secure badge. Besides, we want it to be so that you don't have to specifically check when a connection is HTTPS by looking for the scheme, because Chrome will warn you when it isn't. And for the vast majority of sites, the presence or absence of the www subdomain doesn't make a difference. It's just visual noise for a lot of users who have a hard time finding the security-relevant part of the URL. We now hide these URL components in what we call the steady state of the Omnibox, to make the UI simpler and to focus the user's attention on the security-relevant part of the URL, which is the domain name. You could imagine in the future other possible UI changes that might draw attention to the domain name even more. Should we hide the path of a URL until you click to edit in the Omnibox? Should we make the domain name stand out more by making it bolder or bigger? Should we animate in the path after the user has had a chance to inspect the domain on its own? There are lots of different possibilities, but so far we don't have strong evidence about which one is the best direction, if any, so this is still an open problem. In line with this philosophy, we plan to eventually remove even the lock icon that browsers typically show on HTTPS connections. We plan to present secure HTTPS connections as neutral, as the default, and warn only when the connection lacks security. As you can see here, positive indicators like the lock icon can be confusing to users and send the wrong message. We want to make it so that if you see nothing, you can assume it's secure HTTPS, because Chrome will warn you if it's not. However, we don't have a firm timeline for this change for removing the lock icon, because we need some more time for research and preparation still. Now, not everybody wants their URL display simplified. In fact, many of you in the audience might be power users who understand URLs perfectly well and are pretty good at telling when a site is being misleading about its identity. We want to build tools just for power users like you who understand the underlying identity system of the web well. Our first foray into this space is a Chrome extension called Suspicious Site Reporter. And it does a couple of things that might be of interest to people like you, who want to see the full details about the web pages they're visiting. So first of all, when you install this extension, you'll always see the full unedited URL in the Omnibox. It'll let you bypass any simplifications that we make to the Omnibox in default Chrome with the aim of helping less technical users. Secondly, we think that experts play an important role in protecting the masses on the web. The extension gives you an easy way to report malicious sites to Google's Safe Browsing service, which scans the web for malicious activity. For example, if we go back to that suspicious bank website that I mentioned at the beginning of the talk, suppose that you, as an expert user, received this link from an email and noticed that it looks like a phishing site. Maybe it doesn't look like your bank's normal domain, or you know that your real bank wouldn't ask you to do something like provide your password over the phone. So in these circumstances, if you open up the Suspicious Site Reporter extension, you'll see some more information about that site, highlighting maybe that it's not a top site that users visit often, maybe it's a site you've never visited before yourself, and maybe pointing out some behaviors that suspicious sites typically exhibit. From there, if you decide the site is indeed suspicious, it's one click to report the URL to Safe Browsing for scanning. And if Safe Browsing finds that the site is indeed malicious, seeing evidence that it violates our policies on phishing or malware distribution or social engineering, it'll block the site for all users of Chrome. So as technical experts, you have an ability to stop malicious sites that non-technical people might not have, and you can use that ability to protect all users of the web. You can install the extension from this URL, or if you want to get even further involved, the code is on GitHub, and we'd welcome your issues that you want to file or any code that you want to contribute. Building usable security tools is a really hard problem. But Chrome is committed to helping people understand where they are on the web. We're doing this by combating spoofing, drawing people's attention to what they need to understand to make security decisions, and harnessing the power of experts like you. But web users today aren't just concerned about first-party website identity. They're also concerned with third parties and how their data flows among those third parties. I'll now hand it over to my colleague Michael to talk about limiting what data is being observed about you on the web while enabling a thriving web ecosystem. Thank you.
Hi, I'm Michael Kleber, and I'm a software engineer working on privacy and tracking prevention in Chrome. So let's talk about third parties on the web. As Emily says, when you're visiting a site on the web, the browser can do a lot to help you know what site you're on. But most sites aren't constructed in-house from the ground up. Just like most homeowners get a professional to do their electrical work, lots of websites have third-party experts to do their analytics or their video serving or other specialized functions for them. Third parties are great, and the fact that this is possible is pretty amazing. Composability is one of the web's superpowers. One huge role third parties play today is ads. Sure, Google and Facebook put ads on their own sites, but that's not what I'm talking about. Most ads on the web come from third parties. When you visit a news site, it probably has ads that were placed there. It could be by Google or Facebook, or could be by 100 other companies in the ad placing business. And that's great too. Sites across the web full of important and useful content that people get to see for free support themselves with tens of billions of dollars a year from ads placed by third parties. But there's a problem with this system today, and I'm sure you know what it is: privacy. If you're browsing the web, then even if you know where you are, what site you're visiting, you probably don't know all the third parties that are involved. And it's unreasonable to expect you to. What's more, if you're a developer building your own site, you might not know all the third parties who could be pulled in when it runs. This is like knowing your whole supply chain. Transitive dependencies are hard. And even if you know who they are, you still might not know everything that they're doing. And the answer is it shouldn't matter. People should be able to browse the web without worrying that someone is collecting a dossier on them for what they're doing. And developers should be able to build sites without worrying that their infrastructure is compromising their users' interests. So, how can we get there? How can we let third parties do the hugely important things that they do today, including letting ads pay for content, without allowing specific people to be tracked across the web? We have a two-step plan to get to a flourishing web without tracking. First, we want to give third parties new tools to accomplish their goals. That's probably not what you expected me to say, right? But bear with me a minute. Third parties may want to answer some very natural and non-personal questions. Things like, how many different people saw my ad? Or how often do the people who click on these ads actually buy something? Or is there someone who can vouch for you being a trustworthy human web user? Answering all these questions today relies on a really powerful capability: global cross-site identity. And this is what can also be used to knit your browsing behavior together into a user profile. We would be much better off if it were possible to answer these questions with more right-sized APIs. We need a web that is powerful enough to support those vital third-party use cases without relying on a too large tracking mechanism that gives you way more information than what you really need. It turns out that support for some of these use cases isn't easy. We don't want the browser to share your activity with anyone else, not even with a trusted counting service or a spam detection provider. And that means we need to do things the hard way, with powerful machinery doing privacy-preserving operations behind the scenes. Privacy-preserving measurement and fraud prevention? Well, we've published proposals backed by cutting-edge crypto and secure multi-party computation research. Check out the private join and compute blog post and video for some related prior work. Even harder are the ways that the browser can support those ad companies who want to show you ads that you're most likely to be interested in. We have ideas here too, built on top of on-device and federated computation and guarded by differential privacy protections. Check out Google's federated learning website for some more details. I know it's odd to think about something specifically meant to help ads being built into web browsers. But the browser is the place where we can offer privacy guarantees, and these capabilities turn out to be really important for the web to flourish. How important? Well, our friends in Google Ads ran some experiments on life without personalization or these sorts of new capabilities, and the results are pretty devastating. Websites got 52% less ads revenue on average, and news publishers got 62% less. I'm sure you all can imagine what losing half of their money would do to the websites you love. And that's why Chrome believes that this work is worthwhile and necessary to the health of the web. And look, I know some of you are looking at this slide and saying, oh, this is just about Chrome helping Google protect its bottom line. So let me be clear here. Google makes most of its money from search ads. And people only come to google.com to search for stuff because all the richness of the web exists. Helping the open web thrive is the mission for Chrome and is vital to Google, and I think is why we're all here today. So, part one of my plan was new APIs, and these APIs are built to support their use cases even in a world where there's no way to link up your activity across different sites. So once we've invented new ways for the web to flourish, ways that don't rely on tracking, what does that unlock? How do we move to a world where people who use the web are going to be safe and feel confident in their browsing? Recognizing users across sites has historically been based on third-party cookies. But as browsers have restricted access to those cookies, we've seen them replaced with other mechanisms. Covert browser storage, device fingerprinting, asking for user-provided information like email addresses. Those covert tracking techniques are a real problem. They lack transparency into who's using them and for what purpose, and often there is no way to reset them. We've started landing changes in Chrome to block some of these ways of tracking. To be honest, there are a lot of ways that you might try to track users, and so fixing them is going to be a long road, not a quick fix. And we'll be carefully watching the impact on good use cases along the way. Something like shared caches can be a tracking vector, for example, but they also help pages load faster. Speaking of good use cases, remember what I said about us being much better off if it were possible to answer questions with more right-sized APIs? This applies to the covert tracking problem also. Check out this code. What's going on here? Looks like someone is writing a string of characters to a canvas element and then reading the pixels back, maybe to fingerprint you based on your graphic stack, for example. No, it turns out this is WordPress. The writes to canvas are read back to check whether this string of emoji here, with zero width joins in between them, renders as 3 separate characters like this, or as this one character added in emoji 12. If the web platform forces you to use high-entropy fingerprinting surfaces to perform mundane tasks like checking for emoji support, that's a problem that we need to fix. And then we want Chrome to notice it and stop it when a website is abusing a bunch of unrelated high-entropy content APIs as a way to fingerprint you. Our privacy budget explainer describes the multi-step process that we're working on. As for third-party cookies themselves, let me start with some upcoming changes that we announced earlier this year. Starting in Chrome M80, that's 3 months from now, if you set a cookie the way you've probably been doing it since the dawn of the web, that cookie will be available only in a first-party context. If you want that cookie when you're a third party, you need to do something new. For details, see the Chromium blog post linked here, or see the console warnings that are live in Chrome right now. But the quick summary is this. If you want a cookie available when you're a third party, you will need to explicitly set it with the attributes same site equals none and secure. And yes, that secure thing does mean that HTTPS is a must. There will be no third-party cookies on insecure HTTP requests. This was part of an IETF draft. We expect both Firefox and Microsoft Edge to ship this change sometime next year as well. This is the new world. OK, so what about third-party cookies over HTTPS then? I'm sure some of you are hoping that I will tell you the future, that I'm going to gaze into my cookie dough-flavored crystal ball and tell you whether cookies are going to stick around in their current form, or go away entirely, or live on with some restrictions that prevent their use in cross-site tracking. And I wish I had an answer for you. People's expectations are changing, and all of us in the browser community are watching those changes happen. And it's difficult to predict, especially about the future. Google as a company and Chrome as a browser cannot unilaterally chart the future of the cookie. We can make the current web architecture better by introducing more privacy-safe ways to do important things, and we can build for every eventuality. So what I can say is that Chrome wants to build a web that thrives even if third-party cookies go away entirely. And this is where we need your help. Help us imagine a world without third-party cookies or other tracking vectors. What other use cases are crying out for specialized browser support before we can land there? What new primitive capabilities does the web platform require to get as much utility as possible without allowing user tracking? The Chromium Privacy Sandbox page links to the explainers that we've published so far. And tomorrow morning, there's a talk by Chris and Yoav about the blink process, what an explainer is, and the conversations that we have in public where we figure out what to ship to solve problems and what problems need solving in the first place. Please join us. There are hard trade-offs and difficult design problems here. Let's solve them together. Thank you.